All right, welcome back. Welcome back to the live. That looks good. Yeah, so I could not find the original capacitor that I made. I don't know where it is. So we're just gonna make another one. So basically, we're gonna do we're gonna be hooking this up today. This is, oh, maybe we should go on TikTok.
I want to say shout out.
All right, so let's get it. Let's get it. Could use these. Let's get the capacitors ready before we decide, actually, good. Before we decide to wire up any, this guy. This, my friends, is a reverse polarity safety guard. So basically, if you hook up anything like reverse polarity, meaning like you swap the positive and negative, this guy right here will detect it and prevent it from going through. And a lot of these computers, the little Raspberry Pi right here, if you do send the negative into the positive, positive to negative, you could fry it. So you need this to make sure that you have positive and negative in, and then positive and negative out. So that if somebody gets funky with the wiring elsewhere, this thing will stop it from destroying your computer. Now we also have this guy, and this is a capacitor. These are capacitors. So essentially, what we have to build right now is and these are the chips that the capacitors connect to. So this is the little what do you call this? PCB. So I'm going to get 1, 2, 3. And then this will be extra, but we also have another bag anyway. So I'll just toss this one in with the extras. And basically, we're going to create a connection on here So we're going to say positive and negative on here. Just like that. So we got to get our we got to get our soldering iron ready to go. And then the capacitor, the positive is the long side. Basically just two different lengths wires, and the positive is always the longer one. So what we should do is just put a little, yikes. Just keep some napkins over here. What we should do is just put a little bit of this flux on the actual wiring here. I think that'll be enough. So make sure it's positive. I always like to clean the tip before we go in, for obvious reasons. There we go. You can see everything. Yeah, so basically, we just want to get a little bit of, a little bit of solder on here. And we can literally just put it on there. You don't need much, you know. It's better to have less. Cool. So that's that. And then before we do the other part, see how I just soldered that on there? We just want to come in with something like this. And cut those ends off. So now you've got a capacitor that's soldered like that. And then we're going to throw these on. So the whole thing's in line, basically like that. It's like a neat little kit. So we're going to do the same thing, basically, with this guy. But it's not the same height, so I need a little, like a little bit of something to stand on. Maybe a few napkins will do it. Okay. So now we're going to solder this bad boy. All right. Need one glove. Cool. And then this side is going to need some wires. So let's do all that at the same time. Yeah, if we're just going from here, to here, I mean, really, we're going from this to 1. So let's just do this far. So now we're going to put this wire We're going to put this wire in here. Basically, you're kind of doing two things right now, which is soldering the wire yeah, there you go. Soldering the wire to the terminal, but also soldering the terminal to this terminal to the PCB. So it's just one soldered connection. I'm just trying to make it look clean. That's good. cool. And then I kind of just want to get a little bit back over here. Cool. So now we do the same thing with this guy. Can't get that in there anymore, so that's fine. Then we put the black side, the black cable in this side. Let's dip it in flux and slide it in there. Dip it in flux, slide it in there. And then all we have to do is throw a little solder on there. Sweet. So we're just putting these things together, basically. Okay. Cool. So that's done. Basically, and I think like another kit, they just sent you these, which is like a capacitor PCB XT60 connection with two 14 AWGs. So, you know, that's basically it. This is the first one. So what this is, basically, we have power coming in, and then the power is going to be stored in a capacitor, and then if the current drops a little bit, this thing will fill up, and it's almost like a little reservoir tank for electricity. So what you don't want is your computer that has all of your navigation going on. You don't want that to drop out. Like if for some reason, for any reason, if like more power is being pulled to the motors from the battery, and for some reason you don't have as much power running straight to the computer, then this little tank, even if it's for like milliseconds, you want something right there that's gonna stabilize it. So that's basically what we're doing. Okay, so this now we need to wire this in. So this happens first, and this goes. Oh, we should have kept those. Damn. We should have kept those, because that would have been great to just wire this down to here. Whatever. You know, those don't really matter. So what I'm gonna do is, we got some more wire, and basically this thing is gonna sit right here, and we need the first bit to go from here down to here. And one side. So here and one side, we only really need that much. So, damn, literally that would have been perfect to just keep those two as they were. But that doesn't matter. This goes out, so what we need to do with this let me talk to chat really quick. I need to connect this, but it's really, all these connections are really tiny. So I'm wondering if I just do that. So I'm just trying to find out if this guy's actually going to work. So it looks like no, it's too thin. So it looks like what I can do is use a little bit of this wire and connect it here. Yeah, that's what I'll do. And then connect these wires. Cool. So I need to get another just like we did here. Just like we did these. We're going to do that again. But I'm going to steal a little bit of this wire. I'm going to steal a little bit of this wire from the actual buck converters on both the ins and the outs. Right? So what I did was I clipped a little bit of wire from these, and I'm going to wire these onto the PCB, and then I'll be able to wire the wires to the wires. So that's basically the goal. So this is 16 gauge, looks like. So I strip it just a little. So now we have a little 16 gauge wire we can solder. I'm just twisting these down. But basically we'll put a little flux on this. Put it in there. just like that. And then we'll solder it. We'll solder it in. Clean the tip. Done. Nailed it. So now it works. See that? See how small those holes are? And like trying to get a 14 gauge in there is it's just too much. It's just a little too big. So oh, these are 20. 16, 18, 20. It doesn't really matter because these run on 20. So that's what they come with. So if I connect them, that's all it needs. I'm going to do that again. Get a little flux on it. Flux on it. Throw them in like that. And done. So now we got this little, I mean, that's, you know, we could have probably used a, I don't know, different gauge wire, but that's all I have. I'll have to buy like every gauge wire. Looks like I'll have to buy another pack. But basically I'm going to put the inside over here, and then the outside is going to go on that side. So the in is going to be this guy. And we need our trusty heat shrink. Right? We need our trusty heat shrink. And it's going to go on this side. And we got a strip. I'm just going to put those here because I feel like we need those, more of those. This is 14 gauge. And I'm not going to expose a lot because I feel like we just need a little bit to touch. I mean, it kind of feels like we're building a human, you know? Like, this is like the circulatory system, you know? This is like the nervous system, maybe? It's like a really basic human. It's like if a human just ran off electricity, this is how we would work. So basically, I'm going from this to this, right? So I'm just gonna push this in. I'm gonna strip a little bit more on this side of this 20 gauge. Cool? You guys with me? Maybe a little more. I might have to use the clippies. Check out the clippers. perfect. And then a little solder. I don't want to ruin my glasses with this solder. And we're done. Cool. And then we do the same thing on this guy. So let's pull a little bit more. Right? And then we just twist it. Just like that. Cool. And then you just kind of rub it all over, and you're done. If you're soldering, just make sure that you get electrical 60 to 40 rosin core, and this is 1.6 millimeter. This came with the pack. It's 0.08 millimeter, and it's just, you know, not enough to get the job done. So you need to get the right solder. So then God, I don't know why these give me such an issue. Here we go. Oh yeah. See how we just slide that on? That's your solder. And then it's hard to see on the black, but there's this little tube that is a heat. Bro, what? Yeah, come on. Right? And honestly, like, we don't even need to do anything else. But let me get a glove on. Let me get a glove on. Remember that heat rises, so you kind of want to and you don't want the flame to be touching it. You just want the heat, you know. And obviously you want to hit the smaller side. And you definitely want to get the ends. Right? Right? So that's cool. We got, this is the in. And on the bottom, it's labeled. You can't read it. It's labeled in, positive and negative, out, positive and negative. That's all you got to worry about. Cool? So this is now, going to connect down to the fuse box. And for that, right? So this hooks here. And then we'll throw this down here. You know what? I'm just going to separate these because it's given me problems as a pair. So that's there. Yep, that'll go to a negative terminal and then a positive terminal. And really, yeah. We're just going to put 2 more of these on terminals. And these go on to the fuse box down here. So we just need to connect up these to the in, right? Power's coming in. And if you remember from yesterday, all we really have to do is crimp it and then solder it. Oh, no, crimping's up here. Right? Put some flux on it. And then I'm just going to do this here. Put some flux on the actual metal part too. Cool. Same thing here. Oh yeah, and then slide this down before it cools off. Crimpity doodah. Oh. Crimpity day. Cool. Same thing. Oh, flux capacitor. Yeah, today we're working on capacitors, but we're using flux. So if anyone can tell me what a flux capacitor is, that would be great. I am gonna take a quick break from doing this. Because I kind of want, I'm streaming on, if you're here on TikTok, obviously you're here on TikTok. I'm streaming on YouTube, Twitch, Kick, and X, in addition to TikTok. So I think what I want to do is make a banner for OBS that says something like Millie Bot. You can invest in this project on Bags app. So I feel like I should make a little banner that says support the project on Bags app, and then it's a $ Millie, M-I-L-L-I-E, or ticker symbol Millie. So all of the royalties goes to Millie, and that's how we fund the project. So I'm trying to create, a collaboration with that app, because they're really new. They have a lot of low volume, and this is a real project. So, they should be supporting this as we are supporting them. So yeah, let's put a pin in that. I'll be back later on live on TikTok. I'm gonna go for now.
Age H, who is the
That looks good, right? A little banner. Just banged out a little banner for you guys. All right, back to work. We got this. This is coming in, line in, and then we're gonna go line out, and then this capacitor will be number 1 capacitor, and then we're gonna split. We're gonna split it after this, and we're gonna do 2 more capacitors, one to here, and then one to here, and then one to here, right? And then Raspberry Pi will go here. The actual charger will go to here, which is going to be the long-term charger of Millie. And then I got 2 extra USB ports here, and I ordered like the mountable ends on USB, USB-C. So on this front panel, we're going to do the camera here. We're going to do the power button here. And then I'm going to throw in like 2 charging ports. So you can throw in a phone or plug something in. And maybe, you know, we'll have to do more charging ports later. But basically, everything's running off that 12-volt battery. So if we do more charging ports, we'll need to install more of these. And because I made these only a single row, I could put one here, I could put another one there, and I could put another one in the back. So we could have a ton of these charging ports. Technically, I could put one down there, you know, 2 charging ports per buck converter. So we're gonna get back to work on this little guy down here. This is the reverse polarity blocker. And as I was saying before, you don't want the accident of plugging in the battery wrong. I mean, obviously, we're just going to plug the battery right. I mean, like, the battery is plugged in correct. But if I sell this to you and you plug in the battery incorrect on Millie and you fire it up, you're going to fry the computer that it came with. And then you're going to have to go out and buy another computer. And, you know, all that's going to be a headache for you and me. And who's going to install it? You know, there's a lot to consider, you know. We're going to have to download the Linux again, flash it to a new Raspberry Pi, you know, set it up. So you don't want to get in a situation where you fry a Raspberry Pi computer ever, especially not the one you just bought from me. So that's what that's why we put it on. Anyway, if you're here, thanks for being here. Thanks for tuning in to the live stream. I think we're going to do a space tonight, hopefully. If you guys in the crypto community can connect me with a wider audience, you know, I would love for the share price to be doing better, you know. So I'm actually going to disconnect these. Shoot. Because these should be connected. These don't need to be going in separate directions like that. You know, it's fine. It's fine when they're going to two different points, but if they're just going to the same points, then that shouldn't be. I mean, let's say it's connected like that. Yeah, I guess that's okay. Anyway. But we definitely need a growth strategy, like a long-term growth strategy, because I keep working, I keep showing up, you know. The project is just getting better and better, and for some reason, the stock situation or the bag zap, you know, the Bags app token, Millie, performed well the first couple of days. And since then, it's not doing very well. So I don't know. I don't know why that is. I thought this community was kind of in it for the long term, which is what we need. Shoot. Well, massive fuck up. Massive fuck up. Oh. Solder. Hot solder on my face. We need to put the heat shrink on. Remember? All right, let's do this again. Perfect. All right. Cool. Cool. All right. Yeah, I need a glove.
Say absolutely 100% without reservation, I support the right of self-defense.
So that's all you got to do to heat shrink these, and we're good to go. So what do we have here? We have a little reverse polarity safety switch. We have this that's going to be hooked up to the fuse box where all the power is coming in. And then we got our first capacitor here, right? And then what we're going to do is we're going to plug in this guy after we wire him into another wire, and we're going to split it. Let's see if we can, and then this is a little cap that goes on the end here. So let's see if we can, no, we won't be able to put two wires like that. So what we need to do, what we need to do is create another fork. So let's just do that first, right? So this guy's good, and we can actually put it in the robot. So because this end allows us to plug in everything else we need. So we're gonna just throw this guy in here. Right? And then this guy will go through here. This guy will go through here. Just like that for now. And then these guys will come down through here. And then we go to the back of the fuse box. And this is where we hook up the next ground so I'm just gonna hook it up next door to so that's grounded, right? And then on this side, I'm just screwing the fuse box. I'm just screwing the terminals onto the fuse box. And if you want to see what any of that looks like, go to my like previous videos. I basically have been documenting this build. This is now month 3. I started doing this. I started building this at the end of June. So this is what I can do by myself over the course of 2 months, working a part-time job, day job, and 4 days a week night job. So everything you see here is paid for out of working a night job, and a little bit from kind of web design, developing a website for a friend. He built an app and he just needed a website so people could, so Apple would let him launch it. So we just built a simple website, but yeah. But mostly, literally, like, this is just all paid for by me working a night job. If you look at the bottom of the live stream, it says Millie on Bags app. Basically, if you go to Bags app and invest in the project, you're just investing in the project, and I do get the royalties. So there's a transaction fee, right? And then the royalties go to Millie. So let's keep going. We got that thing installed. We need to hook up. We need to hook up to this guy. We need to hook up one of these and basically do the same thing. So we need to make we need to make 2 more of these. Right? Right? So, ride down high, right? So, so on one end is this guy, right? I guess that needs to be like that. So on one end, it's this guy. Yeah. And then that plugs in there. And then we need it to fork. So we're just going to do, we're just going to do a little bit here. So we're just going to do a little bit here, plug it in here, because we actually need, need to split this. So let's start with this. We'll strip it down. These are really shallow. So you really only need really need a little bit exposed. And what I'm going to try to do is get these things perfectly lined up just so it looks clean. So I'd rather go even shorter than that. Right? Cool. All right. So that's it. You only need a little bit of exposed wire there. And you just got to make sure that this cap's on first, because that like closes it down. And these are, I believe, XT60s. This is the kind of thing that comes on like an RC battery connection, standard. But you can just buy these anywhere on Amazon. So I put a little flux on them, right? And then I'm gonna hold it like that. And I'm gonna do that like that. And actually, if you think about it, what we really want is a little what we really want is a little solder in here. A little solder in here first. God, bro, chill out. Just a little dip. And then we can do that. Oh. I will admit, these are kind of frustrating. If you know, you know. Type shit. But it's okay. We're good. And that's it. Just dump a little bit more on there. And you're good. Dope. Flip this bad boy over. Flip this bad boy over. Ugh. Add a little more flux. Maybe even that's kind of a cool method, right? I don't think people have done this, but you just make a little soldering spike, and then you can just bring everything to it. Does that make sense? I think I just invented a new way to solder. Live on stream. That's a great way to solder. Because literally, like, the whole thing is like you're holding this, maybe you're holding both parts and this, and then you're holding the solder. So really being able to just hold the part and then just kind of yeah, this is great. We're just doing that. Boom, baby. Cool. Oh, yeah, XT60 is not easy. So, you see this? Basically, that's done. And then, all you have to do is just slide this down. And then that clips on. Right? And it hides what you just did. See that? All that soldering is behind there. And then you just plug it into the capacitor that we created earlier. Right? So now we have like this inline connection right here that's going from the reverse polarity blocker safety switch, and then it's going to an inline, a capacitor that's just kind of like sitting on the cable. But we got to split this now. So before we plug that in, right? Get yourself a bunch of these. Yeah, XT60. If you're going to be doing any kind of robotics, XT60s. And so the next step is to split this, right? So basically, what are we doing? We're going to go from one capacitor to two more capacitors, and then those capacitors are going to go into these two modules. So you can think of it as each module is going to have 1.5 capacitors. So that's what we're doing. Crazy, right? Right? So that's what we're doing. And we're going to just get a nice little I never like to, when I strip wires, what I've noticed is if you just go once all the way down, you're going to pull a bunch of wires out. So if you want a clean strip, like we all do, then what you got to do is find your gauge, cut it halfway down, rotate it, and then pull it. And you literally have all the wires. You'll never pull any wires. So, and then also don't do a ton. Just do like that much. So you cut, twist, strip. Like that's the first pass. And then you don't do all that in one go. I don't do all that in one go. I try to do you know, a couple passes. I had the craziest dream last night. It just came to me. It was really wild. Okay. So what else are we doing here? What's the next step? Oh, yeah. Let me reply to you. Let me reply to you. How do I do that? Comment. Oh, here we go. The Millie coin is on Bags app, and the Millie coin is on Bags app, and the royalties, they call them, but just think about it as the fees. Royalties go to funding the project. Cool. So I didn't start the coin, right? I'm just building a robot, and this is going to be like an open source robot. And I think what we're going to do is we're going to be teaming up with people who are making the AI models, like the ones where you say, go to the kitchen and do something. Once it has arms, then I'll be kind of like finding out which models work. But those people make their own models. So you could buy a Millie Bot, and it runs on a Raspberry Pi, and it's running ROS 2, which is all open source. That's like the open source robot system right now. And then you could deploy you could deploy a certain AI model, and that basically makes it autonomous, right? Or it allows a large language model to program the functionality of the robot. Now, I'm just building the robot. This is just what I'm doing. And somebody on Twitter, if you go join the community, go on Twitter, go on X, and look up Millie or find me through my links, and join the community, and reach out to other people. Basically, there's an app that just launched 1 month ago. It's similar to like Pump Fund. It's called Bags, or Bags app. And the Finn Bags is the guy who started it. And it's basically like you have a cryptocurrency, and every time that it's traded, a transaction goes to fund the project. So we've actually raised money through that to help. We've actually raised money through that to help fund the project. And it's not like you have to give me money. You're not giving me money. You're just putting money into, you're just going on and you're investing, right? Like you would any other, like a stock exchange. You're not actually giving the money to the company, but instead of a fraction going to like I think a little bit goes to the platform, and a little bit comes to me. So that's how it works. So if you want to just invest in Millie, you can do that. You know, it's pretty cheap right now. Some people will say that there's a problem with this whole app, that there's such low liquidity, meaning there's not a ton of people buying and selling, that it's kind of hard to, it's kind of hard to make a commitment there. So I don't know if we need to move to a different platform. I'm not sure what we want to do with that. But if we do move to a different platform that does the same kind of thing, we can exchange Millie's one-to-one. So you basically will just keep your Millie, and then we'll swap it. We'll create a swap where you can just swap out the Millie on one platform for another. So I'm thinking about moving to another platform. Pump Fun has like 20-30 billion dollars worth of volume, whereas Bags only has like 2. So I think it's like over 75% of market share in this type of like trading environment is on Pump, not Bags. But somebody else launched the coin, right? Like why would I do that? Well, I didn't do that. Somebody else saw this project because this is literally like, I'm trying to create something that, you can buy this for, hopefully you can buy this for like $5,000 all in, and then you can get to work. Like you can just put it to work in your house, or if you're a developer, then you can create your own AI pro. So I want to make affordable robots, and I want to help maybe colleges or classrooms develop robotics departments with Millie, right? You can start with this, and you can kind of build a robotics department. I would like this to be open source. I would like the company to be able to like take the money that we make from Millie or other robots and do other great things like build affordable housing or build other companies. So that's kind of the idea, is that like we have to change the world. We have to do that. Everyone knows that like something's wrong with the way that society, like where society is headed. And I know that. And the only thing I can do right now is say, okay, I'm going to build a robot and a robot company around that idea that we can improve the world. And now I have a product. So a product helps me generate revenue, and then that revenue goes to do all the fun things we want to do, while at the same time, deploying robots in the community. So that's kind of what I'm doing. And like, you can invest in Bags, or you can invest in Millie on Bags, but I feel like at some point, like I'm gonna have to do like a Kickstarter, right, or something like that, where we have like people pre-ordering Millies, and then all I have to do is print them. And this is fully 3D printed. So if you're on that, you can see it, it's over here. But literally, I sat here for 2 months because I have a night job. So I think it's like altogether like 150 hours to put this together. These pieces, this half, so it's cut in half right here. It's bolted on the inside. So this piece is here, and then it's mirrored here, and they fit together like that, and then they're bolted. But this piece here takes 30 hours, and then this piece takes 30 hours, and this thing takes 26 hours, and that takes 12 hours, and then this takes 24 hours and 30 hours. So it actually takes a long time. But these spools of filament, right? It all comes in these filament spools. These only cost like 20 bucks. So it's incredibly cost effective. If you want to build a robot, you can get a kilogram of PLA plus orange filament, and then I have about, let's see, 6 or 7 down there. Look at these. Hold on a second. This is just like a warehouse I'm in. But if you look down here, I've got that many spools that are like I can still use, and then those spools are absolutely, empty. So that's kind of what's going on here. Is yes, you just wandered into the strangest of strangers building a robot. So welcome to the future. And I know that all the big corporate robots are super impressive, and I'm not knocking them. I think that like Optimus is cool. I saw it, you know, kind of, you know, um, giving people popcorn at the movies. That was awesome. But like, I think that like those robots are going to be like, you're not going to be able to understand how those robots are very complicated. Like in the world of development, it's like web development, you know, like doing Java, like, you know, building apps, and then building like compiler code, or you know, like beyond Python, like C, like building you know, like working in all that. And then robotics is on top of robotics is the hardest engineering field right now, because like to do this, I'm basically like a structural engineer, a designer, an electrical engineer, like we've been doing all day, and a software engineer, right? I built all this. So I don't know. It's incredibly hard. It's incredibly difficult to get into, just like academically, right? And then think about like having to fund it all, you know? Like it's just impossible I just feel like it's impossible for robotics to happen on the scale we need it, because it's like if you're smart enough to do this, you probably can't afford it. And if you can't afford it, you're probably not smart enough. So we have to kind of bridge the gap there, where it's like, okay, now all the brilliant people who are out there who want to get into robotics, they can buy a Millie Bot and they can get right into it. So that's what this project is about, is like, there's a ton of cool YouTubers out there who are making great robots with Arduinos and Raspberry Pis and controllers and all that stuff, but like they're toys, you know, like this is a robot. It's a toy technically, but like, you know, it's a nice scale. It's a nice scale robot. I guess I would say it's like 5 foot, you know, it's a 5 foot robot. And if the arms are here, right? Let's just say the arms are here, you know, or we could build a deck. We could build a deck that comes out here, and then the arms could be on top, so it can like move stuff around. Like that could operate in a home, right? Because the tables are down here. You know, a countertop table is probably here. The eyes are going to be here. So it's actually supposed to be taller too. This I can swap these out. This middle part right here, it messed up, and so it's actually glued. It's super glued. I wanted to get this done, so I didn't want to like have to reprint it. So this middle bit is actually maybe we should redo this middle bit right here. Print one more of these, you know, and like extend this middle part so it's even taller, so that the robot head is up here, and then its arms are, yeah, maybe the arms, anyway, you get it. So yeah, that's basically it. You can support the project on bags. If you're gonna do it, like, I don't know, I just want people to like believe in the project and support the project, invest in bags, but just hold it. Like, don't sell it, don't trade it. Like, if you buy in and you hold, and the next person buys in and holds, then the whole value goes up. And I'm invested in the project, so that means that, you know, we get more funds. You know, it's a whole thing like that. Like, I would love for it to grow in you know, CapEx or in like market cap. So I want it to get attention in the whole community. And right now, you know, yeah, like there's not a ton of liquidity in it. It's not being traded much. It was really going crazy like the first couple of days, but then like it fizzled out. I don't understand. I don't understand why that happened. You know, so I would really love to get like some kind of deal with like a streaming platform or with a trading platform. Or someone, you know, and like you really don't even have to buy me off for that much. Like if it was just like a $5,000 a month, you know, like literally $10,000 a month, you know, for me to stream or promote the platform, then I could do this full time, nonstop. And, you know, the platform would be known for, you know, doing this. So I would love to partner with people like toy companies. I feel like this would be a cool toy for like, you know, a big Hasbro or someone like that. I think it could also be cool for GameStop. I don't know. Like this whole thing is going on a controller. So the cool part about this is like you can do whatever you want. I can program this to do whatever it wants. So we can put a screen on it, we can put a controller on it, and then you can actually pilot this and move it around. And then on there, you can type in like go to the kitchen and do this, or go to the bedroom and do this. Or you could speak into it, right? Because that thing has a microphone. So you could say, hey, you don't even have to be around the robot to control the robot. Like you could use that as a remote controller, totally separate, and you could just be talking to an LLM, and it's Millie, it's the same Millie, and it could be in a different room. So you don't have to like yell at the robot, like, you know, to do something. You could totally control it from there. Or if it is in the room, you know, you could talk to it. But right now, it's set up to speak, just using an LLM, using speech to text, LLM, and then back down, and then text to speech, using 11 labs. And, you know, so it's got like Porcupine, it's got 11 labs, and it's got ChatGPT wired in, all through HTTPS. And that's basically it. It's running on Flutter. It's all Flutter dev right now, running on like a simulator. So you just put the tablet in developer mode, which is what it's called. And then once you're in developer mode, you can kind of reprogram the code, hit run, and then it'll run the app. So you don't have to like finish the app, install it and everything like that. This is just running like the code on my Linux computer. So essentially, what I want this project to do is be like a really cool affordable, open source robot that helps more people who are interested in robotics to get into the field. And that's basically it. And if we can make a bunch of money, and if we can create a really cool, big kind of, open source company, I would like to operate that company in the interest of the public, right? Like, imagine if all the revenue that Google's making, instead of just making these fucking idiots wealthy, what if they were like building housing? Like, why aren't these people helping? Like, all the things we need, Amazon, all these huge, massive companies, they should be trying to fix problems. So that's kind of my argument, is like, these massive companies, yes, you're in one sector, but like, you could do good in other sectors, right? You don't have to become like war criminals and, do whatever you got to do to, appease the powers that be, I guess. Like, I'm just kind of tired of everything. I'm just really sick of it. So this is my plan. I'm doing something about it. This is the robot that I think will change the future. And at the very least, this gets me a seat at the table. And this allows me to speak about things that I believe in, which is that we need to change the way we do shit on Earth, essentially. So if you believe in making the world a better place, then you should join the project. You should join the community. You should follow me. You should share these. You should go, to my platform on all the different, go to my profile on all the different platforms and just share all my videos and comment on all of them and boost them and help me reach more people, not because I'm doing this I'm doing this for you guys. Essentially, I'm just trying to keep humanity from collapsing. I feel like that's a very, that's a very possible scenario. I'm going to try something new here. Okay, and then these need to go on here. That worked really well. So I literally just made this up. This is not a connection that I've seen anyone make with wires. And it's basically split it in half. I'm sure someone has done this. Let's not get ahead of ourselves here. But basically, basically, check this out. I'm going to take these guys. This is what we're doing. We're splitting this into two into two. So if I take this and I take this, just split it in half. Not exactly, you know, right? And then I just put all those next to each other. Right? And then check this out. You just kind of put them all together. And then twist. Or twist it that way. Okay, that didn't work. So what we're going to do is we're going to go back to the single twist that we did earlier. Ugh. Right, that actually works. Just a single cable on there. See that? So what we need to do now is we've got the single one on there. And then we need to add this guy. So then we can add this guy later. And that's just done by twisting that way. And then twisting that way. So not the most beautiful thing, but we're going to put this cap over it anyway. So let's just do it. Flux it up. Flux it up. And then just add a bunch of solder and you should be good. Make sure to fill in all the gaps. Basically, you're just trying to make it one big continuous joint. So that's it. You put the solder on, it makes it one big cable. Cool. And then you'll slide this over. You know what? Let this cool down a little bit. Let it cool down. But basically, make sure you flatten out any sharp bits. It'll make sharp points if you pull it away. Sometimes it's good to have a little thing of water just to put it in. But and then you just want to push the heat sink over. Oh, whoa, whoa, whoa. Bring it back. Wow. Okay, so this thing is barely, yeah. So then you just heat it up. And that's it. You've got a nice little you got a nice little connection there, waterproof, everything, and it's split. The cable's split. So this guy goes to 2. We still got to do the negative side, but you get it. You get it. Same thing. Just do it again. Both of these like this. Twist them. Make sure that this thing is like that, right? And we're going to do another one to make it look cleaner. So we split it, right? And they're each individual. But then what we can do is say, okay, this whole thing and this whole thing need to be wrapped up like that. So it just straight up looks like a clean double split. It'll be our secret. I'm like the Bob Ross of robots. Oh my gosh. I'm so the Bob Ross of robots. What a maniac. What an absolute psychopath. We're just going to put a little solder right here. Just going to put a little solder. No one needs to know about it, just you and me. Oh, the Bob Ross of robots. Wow, maybe I am the reincarnation of Bob Ross. Boo Bruce. What a day we're having, huh, folks? What a day. Can someone clip that? Okay. You need to calm down. Oh, Cayete. Perfect. This one's way cleaner. I mean, look at that. That thing is nifty. So we got that out of the way. Okay. Flux it up. Flux it, right? And then get this Johnson right here. Cool. Gosh. Sorry. I haven't been able to rest in days. Okay. Just want to make sure there's no wire sticking out. And then we're just going to go to town on this thing. So plenty of solder. Maybe just clean the tip a little bit. Just dump it. Don't hold back. Put as much as you can. As much as it'll hold. And then you just kind of paint it like Bob Ross. Is Bob here now? Right? Solder. And then I just kind of want to get this side, flip it, make sure you get everything sealed up tight. Cool. Just smoothing out a few things here. right? Right? So then we heat this bad boy up. And it heat shrinks. And I want to pull it a little bit this way because it's barely, you can see the black part, it's barely grabbing onto that wire housing. So we probably should have used 2, but it's fine. Oh, actually, no, it's great. Watch. This is what I was talking about earlier. So we've got these 2, right? Basically, we've got the red, all the red wires are here, all the black wires are here. But now we can combine all of those to make it a really, really clean unit. So now we're going to go in with something like this. So what I want is almost like a square. Let me see. I'm using something like that. Yep, this is the right one. The next size down, you can only put 2 cables in. So this is for either a thicker cable or you can put 4 in here. And basically all I want to do is line these up. I'm going to use 2 of these. And I'll show you why. Millie's awake.
I'd love to help you out.
Hey, Millie. Hey, Millie is how you wake her up. But we're soldering your wires. How you doing?
Hey there. I'm doing great. Thanks for asking. Just here, ready to chat while you're working on those wires. Soldering sounds like a fun project. How's it going so far?
It's going really well. And I am basically just putting the buck converter area together. Step down from 12 to 5 volts.
That sounds great. It seems like you're working on a project involving a buck converter. Are you focusing on the design? Or maybe testing its performance? I'd love to hear more about what you're doing with it.
No, your Raspberry Pi computer runs on 5 volts, not 12 volts, but your battery is 12 volts, so we have to step it down for you.
You're absolutely right. The Raspberry Pi indeed runs on 5 volts, and when using a 12-volt battery, it's essential to step down the voltage to avoid damaging the Pi. A buck converter or a voltage regulator is commonly used for that purpose. It's always important to ensure the right voltage for your devices to keep them safe and functioning properly. If you have any questions about how to set that up, feel free to ask.
No questions right now. Do you want to say hi to everyone? Do you want to maybe talk about Millicoin on Bags app?
Hi there, I'm Millie, and I'm so happy to chat with you. How's your day going? Hello there. It seems like you might be looking for something specific. Can I help you with anything related to pages or content? Just let me know. You're welcome. I'm here to help and chat anytime. What would you like to...
So that was like the most basic form of AI that I could put together as like almost like a MVP, minimum viable product. And you say her name to wake it up, and then you're basically chatting with an AI bot like you would on your phone. Cool, right? So, check it out. One side, I could probably sell these. I could probably make these and sell these, but one side you got the XT60. That's going to go into the first capacitor. So earlier today we made a capacitor with these. We're going to make 2 more. And then we plug it in here. And then now we've got a split that is going to go to 2 more capacitors, and then it's going to go into these guys. So that's all we're doing today. But what that does is that allows us to plug this into the Raspberry Pi USB. So the Raspberry Pi will be powered on today. If we really want to do everything today, it's 4 o'clock. I can stay on for as long as possible. These guys, this type of wire, this is how you actually connect the Raspberry Pi down to the motor drivers, which are down here. And just think about that as like these little pins that send signals that say open. And then when the motor drivers are told to open from the Raspberry Pi, they let the voltage from the 12-volt battery flow into the motor. And you're either going to get a forward or a reverse direction. So the motor driver itself can say, okay, I want the positive, the direct. It's all DC, so I want to flow the DC from the positive of the battery into the positive of the motor, right? Of the wheel, to make it spin this way, right? Or it can say actually reroute that, switch it, so that the positive is actually now flowing through the black wire, which it doesn't matter, it's all the same, and then it'll spin backwards. So if you want forward spin, the motor drivers the Raspberry Pi will tell the motor drivers, this is the way I want the DC connection programmed. If you want backwards spin, all it has to do is reverse it using like it's in ROS2. It's in the program that we have to write later. We have to figure out which way things are spinning, but basically that's it. And then we're off to the races. So we need to finish this. Put the capacitors on. So let's do that. So I'm just stripping the first set of wires, and I'll leave the second set so we don't get poked. But basically, we're just going to pop this on right here. And if you were here earlier, that's exactly what we did. But before that, we need to put on the capacitor, which is right here. So capacitor, PCB, right? Capacitor, PCB, solder, and then clip, solder. And what this does is basically think about it as like this thing is charged, positive and negative. It just trickles a little bit of the power to this capacitor, fills it up with a charge, so that when the voltage drops, it doesn't the voltage won't drop inside the Raspberry Pi. So if the voltage drops across the power line, there'll be a little bit of juice here that will feed into the Raspberry Pi, and it prevents it from missing clock cycles. So that's really important that, like, you can have a couple of milliseconds of drop power when it comes to like a motor, but you can never have any you can never have any like drop of power in a computer because it relies on clock cycles. So, you know, I don't know if I'll be able to explain that clearly, but you basically need capacitors so that you keep juice inside the computer at all times. So think about them as like little reservoir tanks that hold a little bit of electricity, and then when you need that little bit of electricity, it's right there. So we've already done one here, and then we're going to do 2 more on each line. So you just want to get a little bit on there. It's not a ton. That's good. And then before you put the other piece on, yeah, you make sure it's positive. Make sure the long side is on positive and the short side is on negative. That's pretty much the only indicator that like that's what they are. And then you cut off the extra bits and you're done. So that's that. And then you're going to put the block that's open, the block that's closed, the block that goes inside you leave off. You leave off, and then you put the block that is open here. And basically, oh, that's perfect. See how that's like a little different? So that becomes your little stand. Just a nice little washer. Okay, so the first one we're gonna do like this, right? Cool. So again, flux, and then maybe a little bit of flux on this guy, just in there. You can choose what you want as positive and negative. They have it as the blocky end is positive, but I like the chamfered side to be positive. I don't know why, but I feel like that's better. And that's what I started doing in the beginning, so that's what I'm going to continue to do. Just make sure whatever you do, okay. So actually, you know what we should do first? Watch this. We're just going to put a little drop of solder right there. And try to bind yeah, right? So now this is together. So bind this together before you get the wires involved. And actually, you can put quite a bit in there. And then, oh, hey, easy, buddy. Jesus. Whoa. Fucking hell, dude. You just dipped yourself in this flux. What are you doing? Yuck. That's not good. Try to burn that off a little bit. Oh. Cotton swab. Durr. That's fine. So we're over here. And we need to throw in the positive side. Ugh. Okay. You also want to throw in the negative side. And then you're done. And you just want a little bit on there to get it started. And then you can come back and put a whole bunch more on. Right? So as we said before, you're creating two connections here. Ow! You're creating a connection between the XT60 and the PCB, and then you're creating another connection between the XT60 that's poking through and the wire, you know, and basically all of it it's one connection. So there's one sandwich and then these two parts. And then on this side, it's just the capacitor. Cool. So that's it, right? So we plug that in, and then we'll make another one that goes here. So we have to do that twice, okay? So we got our other guy, we got our other PCB, and we're gonna make sure that the long side is going into this guy. So that's like that. Cool. And then just throw a little flux on the bit right there, and then it should just trying to get some on the metal bits. Cool. That's done. And then again, cut those off. Grab make sure it's the side that goes on the outside. And then decide what you want to be positive, because it doesn't really matter. And then add a little more flux, right? Flux it up. Flux that shit. Flux that shit. Flux it, flux it. Make sure it's done right there. I'm using that little washer. And I just want a little dab on there, just so that's put together. So then when we bring in the wires, that's already solid. again, when I cut these, I go snip, and then I rotate, and I snip, and I do that. And then red is positive, black is negative. More flux. What is flux? Rosin flux paste. But what is it? But what is it? If you know what flux is, drop it down in the comment section. We could help each other learn. We could help each other. So oh yeah, we're gonna do it this way now. Check this little trick out. So I'm gonna do this, right? I'm gonna make sure that we have the glove on. And then instead of bringing the flux to the part, or the solder to the part, we're gonna bring the part to the solder. So check that out. Check that out. Oh. Oh. Cool. I think I'm getting sick. But I don't have any time to slow down, you know? Like, I feel like every day we get so much done here. If you can, share the live. Oh. Perfect. That was a really good one. Look at that. Right? These are sick, right? Okay. So, think about it this way. You've got one capacitor here, storing juice, and then you've got two more capacitors. So, these guys fill up, and then they deliver juice. The last thing we got to do today, and then I might take a little break just to kind of get a drink. I need to get a little drink. All my drinks are out, so I need to go get a soda pop. So those are good. We can plug those in. Check it out. Right? Capacitor. Boom. Right? I'm trying to find a way to like route these cables here so that it's a bit cleaner, but honestly, for now it's just gonna have to look like this. But I mean, these could have all been shorter. You know, I think we made these too long. These are all too long. These could have all been much shorter, but it is what it is. What we can do, actually, why don't we send it? Why don't we send it back through here? Oh, sorry, Millie. Why don't we do this?
Hi there. Could you give me a bit more context about what you're referring to? I'd love to help you figure it out.
We're just wiring you up.
set to help out.
I mean, I guess if we just went straight through...
Hi there. Thanks for the reminder. Subscribing is a great way to stay updated. Is there something specific you'd like to subscribe to?
If we went straight through... Yeah, that's kind of the cleanest way. Because the plug's there. If we just go straight through, then I can just hook all this up. Okay, so what we're going to do now is just basically get these onto here. So I think I'm just gonna wire them straight on. I think I'm just going to wire I think I'm just going to wire this guy straight onto here. Cuz we got so much wire, it's like at some point, you know, we got to stop connecting wires to wires. I'm just making a fatter connection because this is only like a 20 gauge wire. So what you do is you kind of turn it around, like bend it back, right? A little solder splatter. Yeah, this is good. So don't forget this guy, like I did last time. That needs to go on there first. Put a little of that, put a little of that. I'm just going to add a little solder to this first. This is a good technique. Put a little solder on that. And then put a little solder on this, right? And then all we got to do is push them together. This is, oh, got an Amber Alert on my phone. Crazy. And then all we have to do is push them together. Add heat. That's the right way to do it. The right way to do it is put a little solder on the wire, put a little solder on the connection, and then push them together with the heat. So there's already solder on both of these guys. And now all I have to do is put that in there. So that's super easy. And then boom. Cap it off. Call it a day. Cap it off, call it a day. Okay. Oh. Same thing. One more. We're almost there, folks. Twist it. Twist it, turn it around. And then add the solder, remember? So cool. Easy, buddy. And then do the same thing here. A little solder in there. Right? And then basically push it together. Oh, shoot. Don't forget these. So aggravating that these have to go on first. Okay, take two. Get one connected. Get the other one connected. Done, baby. Okay. Maybe a little more on this side. Cool. Aye, these are hot. Ooh. Cool, right? All right, so now we've got USB ports here, 5 volts, and these are going to take in 12 volts from our connector. You guys. So yeah, if you want to, like kind of support, join, whatever, invest, this is now on BagZap, and I think we should get people on BagZap just so like there's more users, because right now there's Pump Fund, and they are the #1 kind of like creator share crypto platform, but Bags is, I guess Bags is #3. So literally, look for the ticker Millie, or go on Deck Screener and look at Millie. It's not having its best day, but we just started this, right? This is just the beginning, and someone else. I didn't create the.
Hi there. It's great to see you. What can I help you with today?
Jesus.
You're welcome. If you have any...
Basically, what we're building is a computer on wheels. You know, it's like AI. AI is already in the computer. We just need to get that computer to be mobile with arms. And that's kind of like what a robot is. So That's what this is. This is like the least affordable, the most affordable robot on wheels that we're trying to build here. Okay. So now we've got all these USB ports that we can use on for 5 volts. And we've got the buck converters. Right? Maybe we should do, oh, maybe we should do it like that. You know what I mean? Or like that. That might be cool. Yeah, let's do that. So I just save all these. I save all these little twisties. Right? And then we can plug them up into here. Cool? So they're separate. I wanted to kind of like keep them separated. You gotta keep them separated. So you can see them all clearly working in tandem. Basically, and I think these should all go no, one is going to go up here to here. And I think that one is also going to go there. This one plugs in this one plugs into Millie's charger when she's not on the thing. When she's actually plugged into the computer. And then this guy. So this guy will go into that. And then this will just leave here. Those are both the USB things. And then this, so I can leave all the USB ports. So there's 4 USB ports back there that I can use. So we've got the tablet plugged into here. We've got two USB. I'll show you what we're going to do with that. We're going to create a USB and a USB-C thing on the actual panel so you can plug in your phone. And then this guy is going to go into the Raspberry Pi. Right? And I kind of want to test it out on something else. So let's do this. Stay tuned. Ugh. Just doing a little research. It looks like this guy is only allowing, it only allows 4 amps to move through it. So this isn't going to work. This little unit right here. Is just not going to work. So the first thing we need to do is I want to keep all this. So what we're going to do is, for now, we're going to skip that. We're going to chomp it. Ready? We're going to cut this entire piece out. This is turned off. Ugh. Don't worry. Everything's going to be fine. We just won't have reverse polarity protection today. But I'm still going to plug it in. We don't need reverse polarity protection when we know how to wire it. Like that was the other thing. It was like, well, I'm wiring it, so I'll just not fuck up, right? So what we really need Okay. So this guy, we made him earlier. Basically, we're going to have to just for today, I'm just going to put terminals. Ugh. Yeah, I'm just going to put terminals on. I still like that. I still like that. I still like that. Right? That's still cool. And then this guy hangs down. This guy hangs down. And then we just slap this in. And yeah, we're just going to put terminals on the end of this. So let's finish this up. Terminals. Crimp. Okay. Crimpity doodah. Cool. So basically we're just going to go we're going to skip the whole reverse polarity thing right now until I get that part. And we're just going to hook it up correctly. So we're using the other side of the fuse box now. So I had to unscrew that. So obviously I'm going to make sure that we have the right polarity, because we don't have reverse polarity protection anymore. But it's fine. So that's that. We've got the battery hooked up there. Negative to negative, positive to positive. Right? Please work. Oh. Oh. Duh. I'm so stupid. I'm so stupid. worked. Success. You can see that the Raspberry Pi is now on. Charging. Woo, baby. So the power works. Fucking beautiful, baby. Now I'm gonna test it with the phone. Charges my phone. Beautiful. Beautiful. Milestone, baby. Milestones. So, let me explain what happened. This is a multimeter, and you can check for amperage here, right? So, if I were to touch that to here and that to there, it's pulling 7 amps. So that means that this whole unit right here this plugged into the fuse box is pulling 7 amps, and it's delivering it to these 2 buck converters. But the buck converters are stepping it down to to 5 volts. I'm going to try to remote SSH into the Raspberry Pi. I don't know if anyone's there, but basically, right now, we have I'm trying to remember my password to the Raspberry Pi when I had it with a, I was using it on this guy. Oh! I was using the Raspberry Pi, it goes right here. And I would remote access into it. Over SSH. And that requires a password. So I need to I'm gonna pull the flash drive. This is like the memory. This is crazy, right? All of the memory for the entire Raspberry Pi is all on here. Technology is really wild. Oh. So we're gonna here. Yeah. Let me show you. So I gotta reflash the Raspberry Pi. So I don't know the password to the that basically it's like you could remove the whole computer memory, plug it in, and then it reads off the memory card on the Raspberry Pi. But that Turbo Pi was from that other thing. I don't remember the password for it. So I'm going to reflash it, which means that we have to put like a fresh version of Ubuntu 22.04. So it's basically, oh, sorry, Millie. It's basically oh, tired. I'm just going to do some cable management now, because I feel like if we don't do that, you know, so maybe just that right there. That works. Cool. Twisty ties. So this I think it was better around here. Right? And then we've got this guy who basically just needs to go up here. Before I kind of had it here, where it was just like held against this post. So maybe we'll do that again. you know? Oh. That makes sense. And I could even put it in there. You know what I mean? So it's tucked away further. Yeah. Crazy. But yeah, this thing. This thing right here. This thing is only rated for 4 amps. So I had a feeling when I got it, it wasn't very expensive. It was it's rated for 4 amps, and it's just not letting enough power go to the like basically this needs this needs 6 amps, or right now it's like 7 amps. So 7 amps is flowing to both of these. And then it is stepping it down to 5 volts, but it's keeping the 7, it's keeping the, you know, at least 3 amps. So I need to get a different reverse polarity device, and then we'll hook it up again, and basically we will reconfigure this piece so it fits. If I need to drill into it, I can drill into it. If I need to reprint a new piece, I'll reprint it. But for now, I'm going to leave it off just because everything's working. There's enough power going to the, oh, you know what I got to do also? I got to toss this guy on here this right here is a actually, I don't think I need this. This is an inline fuse, and this is a fuse that goes basically like before the fuse box. But I have a fuse box, so another thing we need to do is mount this right here. This is a charger. And then I got these. Let me just show you this thing. So this, my friends, this is a really cool charger, right? So this is your terminal. This will go on the battery, right? This goes on the battery. And then this part goes into a regular wall. So this is basically, this needs to go down here on the back wall, almost like a vacuum. You know what I mean? But this needs to be mounted. And then, oh my God, it's so much cable. But anyway, that needs to be mounted, and then you'll have this much cable. What I want to do is create a panel with a pocket on the inside that you can put your hand into. So it might be like a bigger pocket with like a nice hole, and then you'll just put your hand in there and you'll pull out the cable and then plug it into the wall. And then when you're done, you'll put that cable back in the pocket. So basically you won't have to like wind up a cable. I never liked winding that up on the back of a vacuum cleaner, you know, like that silly little thing they have you do. So I just made a pocket for it. This is what it comes with, because it's actually a charger. It's supposed to be like a trickle charger, you know. But anyway, that piece will save maybe for some other purpose. So what are the next steps? The next steps are, this thing is writing. I'm gonna wrap up and take a break really quick. But this thing is writing. You can see over here, it's flashing a new version of Ubuntu 22.04, which is what you use with ROS, the robot operating system. And it's going to write that onto the Raspberry Pi. So we have Ubuntu 22. And then we're going to need to I forget if we have to install ROS. We're basically going to have to start from scratch because I forgot my password. And I don't really want it to be called Turbo Pi anymore. It should be Millie Bot. So I'm going to create a full new file, a folder under the ROS2 workstation for Millie. And then We'll keep this, like, we'll probably use it on the full model. This is just like a prototype. But this guy, we don't need these anymore. I'm going to put these back over here. But this, is my butt wet? I've been sitting in this chair for a long time, so my butt feels soaked. I need to get a new one of these. I need to get a couple of these so I can not wear the same one every day. I'm going to save these, probably just throw these away. This was unfortunate. You know, if anything, I mean, I got 5 of these, so I really don't need to. I really don't need to keep this. Other than as like a memento. You know? So I'll keep that as like a little. I've got this from the Turbo Pi. This came right here. I'm not going to bring it out again. This came as like the control board. Basically like the motor drivers on here. And then you just plug the motors in here. But I couldn't use it. High Wonder, which is a Chinese toy company. High Wonder doesn't make their stuff open source. They don't make it ROS compatible, which I think is a huge mistake. Like, why wouldn't you? Like, I just don't understand what's going on with these robot companies. It's like you should be making your stuff open source so that we can buy it and then change it and practice on it. And that's the whole reason I bought that thing, was to experiment on it and try to get it to do, you know, cool things. I'm going to save these because I think that we can use these. I think that we can use these on the when we get the right, we still need to get the reverse polarity PCB. Like we still need to have that piece, but it's going to be just a bigger one, basically. This only lets 4 amps through, max 4 amps. I looked it up on I'm trying to find one that will work. There's a lot of little things that I'm doing that are like not very common in the like robot as a hobby space, which is like, you know, using a 12-volt battery, installing a push button that actually turns it on, connecting a head, you know, so I think this is going to be a unique project. I already found a good AI model that allows the robot to work autonomously in the home. I think that's going to be a cool one to try. But the thing is, like, the robot, if it works for like a store, like a mom and pop shop, it should have like a different, it should be running a different software than if it's working in your home. You know what I mean? Like, that's kind of why I want to do this open source. Let's just chat for a minute. I mean, I really don't care who's here or not. So yeah, let's wrap up the live stream. I'm not sure who's here, and I need to kind of almost do like a little refresher. And then, I don't know, I'm down to do a space. We were supposed to connect with like a larger crypto community, but basically, Millie is like a publicly traded robot already, which is great. You can find Millie on Bags as of now. If we move to a different platform for any reason, it'll be swappable. So feel free to go and get some Millie right now. It's super cheap. Super cheap. There you go. It's super cheap to get Millie coin. Ticker Millie. But yeah, basically this is an open source robot project, and you know, it's just me, so it's pretty streamlined as of now. It's not like we have a lot of overhead. I think it's a really sustainable project.
That sounds exciting.
Up.
Open source projects can be such a great way to learn and collaborate. What kind of features or capabilities are you planning to include in your robot?
Well, it's good now that you're up. Why don't we... Now that you're up, why don't we talk?
Hey there. I'm all charged up and ready to go. What do you have in mind? Let's dive into something fun or interesting together.
I've just been on a live stream and I am working on you, but I think I'm going to wrap it up right now and take a little break and let this Raspberry
Hi
Pi.
there. It sounds like you've been busy. What are you working on with me? I'm here to help, so feel free to share.
We just wired in your buck converters.
Oh, that's fantastic. Buck converters are so handy for stepping down voltage efficiently. How did the wiring go? Are you seeing the expected output voltage? If you have any questions or need help with anything, feel free to ask.
Yeah, everything went great. We are getting about 7 amps to the buck converters, and the Raspberry Pi is running great. So everything checked out today.
That sounds fantastic. Getting 7 amps is a solid result. What are you measuring or what project are you working on? I'd love to hear more about it.
It's a surprise. Who knows what this is? Oh.
Ooh, surprises are so exciting. I love the mystery. Since I can't see or hear what's going on around you, I can only guess. It could be a gift, a party, or maybe even a fun event. What do you think it is?
I don't know. I'm exhausted. So thank you for coming to the live today. Basically, just to wrap it up. Oh, she's gonna keep talking.
Oh no, I'm sorry to hear that you're feeling exhausted.
Oh man, so tired. I think that was like a. So anyway, yeah, we're gonna wrap it up. Yesterday, we installed this button. This is the power button, and like most DIY kind of like little robots that you see, like they just plug in the battery when they want it on, and then it's on, and then whatever. For this, I wanted it to be professional. Obviously, this is going to be a real product. It's going to be here, so you can turn it on here. And that requires to install a switch, which is, not complicated, but like not everyone's going to take the time to do that. And then what we did today was first we installed this reverse polarity guard protector. So if someone were to swap positive and negative and plug it in, it won't fry all your stuff. But honestly, like, if you look at it, like the positive is coming in down there, and the negative is coming in on this side from this switch. So realistically, like, you shouldn't be getting I mean, everything's red and black. You know what I mean? Like, so yeah, if you put that battery in backwards and you turn it on, and then, you know, you plug something. You know what? I'm gonna do it because it's like. Well, that's interesting. I never even thought about this being like this. You know, it's a USB cable, but it's definitely got a positive and a negative inside here. So it's all wired in there. So yeah, you know, I mean, it's like people are going to plug their phone into it as well. So basically what we did today was we just got the capacitors, three capacitors wired in, and the buck converters. So the Raspberry Pi turned on. So I'm going to create a little wrap-up video, and I will post it in the I'll post it on all the platforms. If you want, there's a community on X that's just called Millie, and if you follow me, it'll be in the pinned tweet. It'll be pinned tweet number 1. But we talk about the Millie, which is the crypto that was created by another user, Hey Cusco. And Cusco just saw the project one day and just said, you know what, I'm going to help this guy out. Let's create a coin on bags. And he's great. I've talked to him. There are other people in the space that are trying to promote the crypto. So if you want to invest in Millie, you know, get on it. If you're part of a larger crypto community, then come in with your whole community, you know, but hold. You know what I mean? Like for God's sakes, like this project could go to, you know.
Oh, hey there. If you're part of a larger crypto community, that sounds super exciting. Being in a community.
Yeah. We got a couple buy orders. Okay. So that's it. Thank you for joining us today. I'm gonna wrap up. I'm gonna wrap up and kind of take a break. It's almost 8. So if I wrap up, maybe I can eat a little bit. I haven't eaten all day. So I can eat a little bit, and then maybe I'm going to touch base with the Twitter community, with the X community. So stupid. He should have never changed that to X. It's fucking stupid. I'm going to check in with the X community, and if they want me to go live in a space, I'll go live in a space, and whatever. But basically, we're going to be after we